This is the exam review for semester 1. We're working on unit 1. The first part here is that we're trying to determine what a function is. Is when every x value has only one y value. Here we can see that we have the same x and they have different y's, so that is not a function. All these x's have different y's. The same x's have different y's. Not a function. Same thing here. But if you look at this example, all the x's are different. If you were to plot these points out, -1, 1, 1, 1, 2, 5, 3, 4, a vertical line test would never hit 2 points at the same time. It passes the vertical line test. So only letter C represents that. Looking at our domain and range. When we're trying to look at the domain, we're looking at the x values. So here, what x values do we have being represented? Well, we have -1 all the way up to 1. It's not equal to because these are open circles. Using interval notation, that would be -1, 1, and they are both curved because they don't include those points. Now that we look at the range, which is the y values, the y values are what y numbers exist. Well, our y values are going from 0, exactly 0, all the way up until you get to 1. So here, I'm actually going to change that. So 0 is the smallest, it includes that, and it only goes up to almost 1. It does not include 1. What I had earlier was y was greater than or equal to 0. That meant it went up forever. But no, it stops at 1, or stops at almost 1. Your smaller number is 0, your larger number is 1. It includes 0 for interval notation, so we use our square bracket, and we use a rounded bracket. You may use either format in answering your questions. Here we have an interesting one. We have a solid dot. The graph goes up, the graph goes down, and the graph goes up and continues up and over forever. So your domain are the x values, and it goes on forever because we have an arrow that implies it's going to keep moving to the right. So your x is greater than or equal to, because it includes it with a solid dot, -3. Interval notation, it includes -3 and it goes forever to the right, which is infinity. The y values are down low and they go up. Now of course they go up to 3, but they also continue up forever. So we would need to say y is greater than or equal to -2. Because it includes -2, but then it goes up forever. So y is greater than -2. Interval notation, smaller number is -2, and then it goes up to the larger number, infinity. Then to start off our actual Unit 1 portion of it, the exam review, this is an absolute value equation. We have the absolute value bars. So we want to know what numbers inside, when you take the absolute value of it, are going to make 11. Well, that would be 4x plus 3. That might make 11. And also 4x plus 3 might make negative 11. Because the inside might be a positive. What's inside could be a positive 11, or what's inside could be a negative 11. So when we subtract, we'll get 4x equals 8, and x is going to be 2. So when you plug in 2, 4 times 2 is 8, plus 3 is 11. Absolute value of 11 is 11. So 2 is an answer. And when we divide by 4, we're going to get negative 7 halves. And when you plug negative 7 halves into that, you multiply 4 times negative 7, which makes negative 14, which added to the 3 makes negative 11. And when you take the absolute value of that, you get 11. Same thing here. When you take the absolute value of 11, you get 11. So our two answers are x equals 2 and x equals negative 7 halves. We can do the same thing. Maybe you would pause the video, give number 2 a try. Remember, you don't want to just copy what I have. You want to make these decisions on your own. My bad. This was actually a negative 9. So we got two different answers. When we plug in 7, we get 42 minus 9 is 33. The absolute value of 33 is 33. And we plug in negative 4, we get negative 24 minus 9, which is negative 33. Absolute value bars make 33. So now we're going to look which statement is true about the function, the absolute value. Now remember, this is an absolute value equation, so y equals a, x minus h plus k. So we're looking for our h and k. Our h value is 2. Our k value is 4. That's going to be C. And then we're going to look at domain and range. The domain of an absolute value function, thinking about what the graph would look like, it would go 2 to the right and 4 up. And it would have a slope of 1 and negative 1. The domain is going to be all real numbers. And the range is going to be the y values greater than and including 4. Because it's up here at 4, and the graph goes up from there. The end behavior, as x approaches negative infinity, the function y is going to approach, let's take a look. When x is moving to the left, the graph is heading upwards. So up, we call it, goes to infinity. And as x approaches positive infinity, when x goes to the right, the graph is also going up. It approaches positive infinity. Number 4. What is the range of the relation given by these ordered pairs? These are points. Alright, so we're not connecting the dots between the points. These are just the points. So 2 would be the range. Also 3. A 2 again, you don't need to write it again. -5. And then 1. So we like to use those fun brackets. So that would be your best set of answers, which would be letter B. Sometimes when you're working with a multiple choice test, you want to rule out what's wrong with the other ones. Well, this one seemed to have all the numbers. It had 4, it had 1, it had 4, it had -5, it had 7, it had 2. It just had every point. This one here seemed to have a random, let's see, it had the 1, yes, and then it had a y value, then it had an x value. Over here, it had an x value, an x value, an x value, and another x value, but it looks like it must have skipped. It didn't do, oh, these had x values. Not bad. That's exactly what we said. Anyway, B's the answer. So what is the minimum value of the function? Well, there's a couple different ways we can do this one. This is a quadratic. Okay, and the line of symmetry is x equals -b over 2a. This is in standard form. So our b, so our x is going to be negative and -8 over 2 times a. So that's 8 over 4, which is 2. X is going to be 2 for our line of symmetry. Alright. Did I see that one in there? -b, which is 8 over 2 times a. I'm not seeing x equals 2. I see y equals 2. Oh, my bad. Okay, it's a good thing it wasn't here. I would have fallen for it. This was a line of symmetry. We are looking for the minimum value. So the minimum value is the y value at the line of symmetry. So now we have to plug that number in. So we have 2 times 2 squared minus 8 times 2 plus 5. So that gives us 4 times 2 minus 16 plus 5. That's -8 plus 5, which is -3, and that is a y value of -3. The other way you could have done it is to take your calculator and type it into y equals, and type in 2x squared minus 8x plus 5, you can take a look at your graph. Okay, that's really spread out there. So I'm going to put it back to normal. There it goes. And we will look at the minimum value, which is second trace. And it asks you for the left bound, so it wants you to be to the left of where you think the lowest point is, which is right here. I'm to the left of it. Now I'm to the right of it. And it wants you to guess, which means you could get close. As long as there's only one answer, it wouldn't matter. And we're getting the answer of -3. Now it gave us a value that's super close to 2 because it was able to reach -3 with approachment calculations, but it's exactly 2. If we would try 1.999, we would not get exactly -3. So that was another way to get -3. What is the vertex of this function? Well, this is vertex form, and that's y equals a x minus h squared plus k. So your hk is your vertex, so 4, 6 is your vertex. What is our domain and range? Well, this is going to be a parabola. It's going to have a vertex when x is 4 and y is 6. And it's a positive a, so it's opening upwards. So your domain is going to be all real numbers, because you can plug in any x value you want, plus the graph goes forever to the left and forever to the right. The range is starting at 6 and going up. So y is greater than or equal to 6. As x approaches -infinity, the function approaches positive infinity. And as x approaches positive infinity, the function approaches positive infinity. In a quadratic, it's going to be approaching the same direction every time. And not that they're both going to be always positive. If the graph was upside down, they'd both be negative. So we look at what are the roots. We have our quadratic. To find the roots, we're looking for the zeros of the function. So factoring this would be an option. So what multiplies to be -4 and adds to be 5 would be -8 and a positive 5. So when we're doing roots, we're looking for where the function is a 0. So we're going to have x minus 8 equals 0. That gives me x equals 8. And x plus 5 equals 0. It gives me x equals -5. So 8 and -5. That 8 and 3. 8 and 3. Which is a difference of 5. 8 and 3. They add to be -5. See, that's the great part about multiple choice tests. As long as you have a clue what's going on, you make a silly mistake, you can often catch it. So 8 and -3 is A. We're going to factor. That's your A times your C. So A times your C gives you -20. That adds to be 19. -19. So that's going to be 4x squared. Well, we first got to figure out what makes that work, which is going to be 1 and -20. So we have 1x minus 20x minus 5. Circle our groups together. Factor out your x, leaves you with 4x plus 1. Bring down your sign, factor out your 5, 4x plus 1, because negative 5 times a positive 1 gives you a negative 5. That leaves with x minus 5 and 4x plus 1. X negative 5. Here we're looking for the standard form. So if it's adding, we're just going to collect our like terms together. So we get negative 3 and we get negative 3i. We're looking for our solution. Well, one way, because this has no b value, this is in standard form. If this is in standard form, but it has no b value, you could also call this vertex form, to tell you the truth. This could be vertex form with x plus 0 in parentheses, being squared. Either way, it has no b value, so you can add the 4 to the other side, divide by the 3, and take the square root. When you take the square root of a fraction, we can write that as square root of 4 over the square root of 3. Well, the square root of 4 is 2 with the root 3 on bottom. Now we have to rationalize the denominator, which gives us plus or minus 2 root 3 all over root 3 times root 3, which is root 9, but that is 3. Simplify. When you simplify, you're trying to figure out what numbers multiply into 128. There's a couple different ways we could do it. 64 might work, 8 might work, but most people might think of 4. So we'll say 4. 4 goes into 12 3 times. 4 goes into 8 twice. Four goes into 32 4 times. 4 times 8. There's a pair of numbers. So I can bring that pair of numbers out. And 4 times 2 makes 8. There's another perfect square. So I have my 4, my 2 that comes outside with my root 2 inside. So that's 8 root 2. What is true about the number of the types? We're looking for the discriminant. The discriminant is b squared minus 4ac. If it is greater than 0, then you're going to have 2 real solutions. If b squared minus 4ac is equal to 0, you're only going to have 1 real. And if b squared minus 4ac is less than 0, then you're going to have 2 imaginary solutions. So in this case, we're going to get b squared minus 4ac, which is 16 plus 8. That looks like 24. So we're going to get 2 real solutions. Which equation represents our graph? Well, this gives us the intercepts. So we know we can use intercept form. So that would be y equals a, x minus p, x minus q. Here is your x and the y, because those are points right on the curve. These are specifically your x and y value, or your intercepts. So P equals 1 and Q equals 4. So your y is negative 6. You don't know A. X is 2. P is 1. X is 2. Q is 4. So notice, following the formula, we write negative 1. We write negative 4. So notice how it's the opposite of what it really was. So this is 1, this is negative 2. When we divide, we get 3. So A equals 3. There's 2 of them that make A equals 3. So we're going to get our A value to be 3. And we had x minus 1 and x minus 4. So that's the only one. We probably could have figured that out by just looking at the answers. If your P and Q were on the positive side, then it's going to be x minus those positive numbers. X minus 1, x minus 4. Your domain and range. Your domain here is all real numbers. It's a parabola. It's always all real numbers. Now your range. Your range, we would have to figure out what the vertex is. We got to figure out how low it goes. There's multiple ways we can do that. We can find the line of symmetry, which in intercept form is P plus Q divided by 2, and plug that in. But if this is a multiple choice test, you're allowed to use a graphing calculator, and we can say 3 times x minus 1, x minus 4, and we're going to get our graph. We knew what it looked like, but we'll go to second trace, or to the calc menu, and we're looking for minimum, which is number 3. And it's going to ask us for the left bound, so we want to get near the answer but be to the left of it, and we want to get near the answer but be to the right of it. And it says guess, so if you want to get closer, you're welcome to, and hit enter. So we have a negative 6.75. So y is greater than or equal to negative 6.75, because the graph goes up forever after that point. For end behavior, as x approaches negative infinity, our function, which we're calling y, function goes up, goes to positive infinity. And as x approaches the right side, the graph goes up also. Then we're going to have what makes C, what makes this whole problem a perfect square trinomial. What's the C value going to be? So this is called completing the square. So we take our B value divided by 2 and square it. So that's going to be negative 10 divided by 2 and square it. Negative 5 and square it, which is 25. So we're going to get x squared minus 10x plus 25. C equals 25. So if we were looking for our equation, it would be x minus 5 quantity squared. But the question was, what is the C value? And that's the 25.